Hello guys, this is Hani, and today in this video I'm going to tell you about what is the Dalton's atomic theory. Now first I'm going to tell you that what was the full name of Dalton. That was John Dalton, but in this atomic theory it is like Dalton's. We all say it as Dalton's. We don't say it like John Dalton's atomic theory. So in 1808, in 1808, John Dalton, an English school teacher and chemist, suggested the fundamental ideas of atomic theory, which explains the chemical nature of matter and the existence of atoms. It is known as the Dalton's atomic theory. So he was an English school teacher and he was also a chemist. So what he did, he suggested the fundamental ideas of an atomic theory, in which he explained the nature of a matter, the chemical nature of a matter, and the existence of atoms. That how they exist, how are their like chemical, their natures, how they react. Okay, so here are some important postulates of Dalton's atomic theory. So we are going to have a look on it. Important postulates. We're going to write it so that we can remember it carefully. And okay, now yeah, the first one is that all elements are made up of small indivisible indestructible it's indestructible, yeah, indestructible particles called the atoms. Okay, so the first one, it says all about that all elements are made up of small indivisible indestructible particles called atoms. In this one, all I want to say was that atoms are way too small that even we can see them with our naked eyes. But on the other end, he's saying that they are indestructible and indivisible. Well, another thing he was trying to say that elements and even a little thing, the smallest thing, is made up of atoms. They are way too small, even we cannot see them. So now coming to the second one. The second one says that, let me tell you, the second one says that all atoms of a given given element, yeah, given element are identical in all respects, and now he says that having same size, mass, and chemical properties, but the atoms of one element of one element differ from the atoms of other element. Okay, so all you wanted to say was, first we are going to have a look on this one. The second point shows that all atoms of a given element are identical in all respects, having same size, mass, and chemical properties. But the atoms of one element differ from the atoms of other element. That means He's trying to say that all atoms of a given element are identical in all respects. If we are going to have a look on the atoms of an element, so they are identical by having same size, mass, and chemical properties. But the atoms of an element differ. Differ means different. They are different. How they are differentiated. So he was saying that, but the atoms of one element differ from the atoms of other element. It means they are differentiated by they're different from each other, from different elements. From different atoms of one element of another element's atom. So now coming to the third one, that is the second last one. That is that compounds are compounds are when compounds are formed when atoms of more than one element combine to form no sorry combine in a simple whole number ratio. Okay, and this one he wanted to say that compounds are formed. How are compounds formed? In this one he's telling us that how are compounds formed. As you all know that compounds are formed when atoms of more than one element combine in a simple whole number ratio. It means in this point he's telling how are compounds formed, and you all guys know that how are they formed. They are formed by combining more than one elements together with the same whole number ratio. So coming to the fourth one, and over here it says that a chemical, a chemical reaction is a rearrangement of atoms. Okay, atoms, but atoms themselves are not changed. Okay, are not changed. This means that atoms are neither created nor destroyed. Okay, destroyed in a chemical reaction. So over here in the fourth point, all he wanted to say, we're going to have a look on it, that a chemical reaction is a rearrangement of atoms, but atoms themselves are not changed. This means that atoms are neither created nor destroyed in a chemical reaction. So over here, he wanted to say that a chemical reaction is a rearrangement of atoms. It means, and in any chemical reaction, there is a rearrangement of atoms. It means that may contains all atoms. Say all not. We will not say it is as all. We will say that rearrangement of atoms, but atoms themselves are not changed. The atoms remain the same. This means that atoms are neither created nor destroyed in a chemical reaction. It means even if you will check after and before the chemical reaction, the mass, the size of an atom, every single thing will remain the same. Okay, it means the rearrangement of atoms is not changed. Okay, so this is all I wanna tell you guys, and hope you liked my video. And